Hey everybody, welcome to this week's edition of our Tech Talk series. Thank you for joining, welcome back. Today I'm going to be talking to you about automated model deployment pipelines, specifically with AWS's Sagemaker tool. And for those who don't know what that is, it is AWS's service that makes it really easy for data scientists to train and develop machine learning models. So, welcome back. I know this is number 6 of 52. I feel like the year is flying by already. We will be hanging around after this on the general channel to answer any questions. So feel free to stop by if you have anything to talk to us about. Before we jump into today's talk, I wanted to highlight and give you guys a sneak peek of the next 2 weeks ahead. Next week we have a really awesome talk. Brett is going to, you'll hear from him, and he'll share how to integrate Modzy into Tableau. It's a simple plugin extension that for all you dashboarders out there will be able to take your machine learning or take your dashboards to the next level with machine learning really easily. And then the following week, you'll hear from Clayton and Sawmill, who are going to talk to you about automatic model containerization in the same category as the talk I'm going to give today. But they're going to talk about an open source project that we've been developing and are really excited about. So definitely don't want to miss that talk. It's going to be awesome. But today, what are we talking about? Automated model deployment pipeline. What do we mean by that? Well, the main idea is we want to give data scientists the tools to take their machine learning model, however they've built it. In this case, it'll be specific, but that's the general idea, and deploy it into a production setting. And normally, there are a ton of skills and technologies required that data scientists just don't know to make that happen. And so that's what we're going to focus on. So specifically, I'll take a model, walk through an example training of that model in Sagemaker, and deploy it directly into Modzy in a completely automated fashion. You might be wondering, who cares about this? Well, I've mentioned data scientists several times now, and specifically Sagemaker users, but other folks who may use Azure ML, which is Azure's equivalent of Sagemaker, and then MLFlow, which is a really awesome tool that the data scientists can use for tracking their experiments, tuning hyperparameters, and logging, the best metrics as they train. That said, anybody who maybe doesn't come from a data science background, happy to have you and welcome, and hopefully you learned something today. All right. Why might somebody care about this integration, this automated pipeline that I'm going to show? And there's a lot of reasons, but the two I wanted to focus on are, number one, operationalizing machine learning is hard and takes a lot of time. As I mentioned, there is a whole collection of skills required to take a model from point A or experimentation to point B in that production setting. And what I'm going to show makes that really easy. The second is standardization. So we talk about standardization a lot here at Modzy, and I think it's really important because, yes, if there are plenty of organizations who may exclusively use Sagemaker, others may exclusively use MLFlow, others have their own custom model building and development pipeline set up, and that's all well and good. But there are plenty of other organizations that data scientists do different things. And tools change and improve, preferences change, and ultimately what you will find yourself with, at least from what we find, is scenarios where you have dozens of models all saved in different ways. What that means is different file formats. They're all they run differently. They get to load them in different ways. The input files and formats are different. So what we're trying to do is suggest a standardization approach so that you can manage all those models a lot easier. How are we going to do that? There's a service we have within Modzy called the Model Converter Service. You can just think about it as how do I add a model into production? So on that note, a little bit of background. Today, there are a few different ways to get your model into Modzy. This diagram is admittedly overwhelming, so I'll simplify it and just talk about model converter, which is what we're going to talk about today. And you'll notice there's a whole collection of different tools and things that are in between model development and model deployment below. What you'll notice, though, is that our converter service totally bypasses all of that. So that the goal is any data scientist who trains their model in SageMaker, MLFlow, or Azure ML doesn't have to do anything and can get a model into production really quickly. In other words, it bridges that gap for them. So speaking of bridges, if you have attended some of our recent tech talks in the last 6 weeks, you'll notice I'm stealing a page from Seth and Brett's book. They talked about the AI Valley of Death a couple times. This idea that on the left side, there are all these tools and processes that data scientists follow and know really well. And on the right side, there's all these DevOps tools and processes that they know really well. But it's really hard to get from one end of the valley to the other. And broadly speaking, Seth talked about how MLOps is the solution to this problem where we're applying everything that we've learned about DevOps to AI. So I'm going to modify that a little bit and use this bridge analogy where this converter service is going to be that bridge. So again, on the left, we have the development and training side of things. On the right, there's production. Data scientists know TensorFlow, PyTorch, MLFlow. They typically will use a combination of these technologies, and they work with these every single day. That is their full-time job, and they're really, really good at it. And then when we talk about production, a lot of these terms, get thrown out there. From a monitoring standpoint, explainability and drift detection. From a business side of view, how do we generate business value and insights? How do we manage our costs? How do we do so in a secure environment with user management? How do we make machine learning easily accessible through APIs and SDKs? If I were to ask all those questions to a data scientist who knows everything on the left really well, oftentimes 9 out of 10 would say, I have no idea. and the reason is because there are so many additional technologies and skills required to truly bridge that gap. From an infrastructure standpoint, different cloud infrastructures, orchestration, Kubernetes, containers run on Kubernetes, and typically you use Docker to do so. When we talk about building APIs, you need to know about web servers, gRPC, Flask, and manage all your code in GitHub at the same time. And it's a very overwhelming set of tools and collections. So what if I told that same data scientists, you don't have to know any of that, and instead could just use this converter service that we've built here at Modzy that, again, just totally bridges that gap and acts as the intermediary between what a data scientist is really good at and a MLOps platform. So that's what I'm going to demo in a second. Again, this service is going to, or the demo will be SageMaker specific, but it applies to Azure ML, MLFlow as well, and we'll deploy this model right into Modzy, our MLOps platform that just so happens to offer all those things that I talked about in terms of functionality and features. All right, I will stop there before jumping into the demo and see if anybody has any questions. If not, that is totally fine as well, and I will move on to, let's see. I will move on to the demo component. So can you guys see, can somebody acknowledge they can see SageMaker here?
Yes, we can.
You got it.
Awesome. So again, I'm going to show an example of training a model in SageMaker and automatically deploying that to Modzy. For those who maybe have never used SageMaker but know Amazon, SageMaker is just this tool that in the same interface with all these options for data scientists to build their models. So what we're going to do is look in the notebook instances. Of course, I should have done that right before. 1 second. SageMaker, let's see. And go into notebooks. All right, And so I'm going to click on this integration example that I created already. I already have it open in Jupyter. And so this looks like just a normal vanilla Jupyter notebook that's running in Sagemaker. What I'm going to walk through is actually a tutorial that Sagemaker offers for image classification. So just walking through here, we'll go through this step by step. The purpose of this is not to show a Sagemaker demo, but instead to show that this is a process that data scientists use and perform every day. So we'll start by importing the packages we need and defining the S3 bucket where we'll store our model artifacts and training data. Fun fact, actually, this is kind of off topic, but for those who know AWS and have used Boto 3, the Python SDK, again, official SDK to access and interact with AWS services, you may know the answer to this, but I didn't until this morning. I've always wondered why it's called Boto. Well, came to find out that it is derived from a Portuguese name of a dolphin native to the Amazon River. And so I did a little Googling and found that this dolphin is what the Amazon or AWS SDK is named after. So I thought that was kind of a fun little fact. I have an ugly dolphin, if you ask me, but anywho, so we've imported the packages we need, defined our buckets, and now we're going to prep our data. So what we're doing is we're going to download the data and upload it to this S3 bucket where we're going to store it for training. And then getting into the training component, we're going to train a ResNet model, which is a very common architecture for image classification and segmentation tasks. And we're going to train it on a Caltech data set, which contains images spread out from 256 different classes, object classes, again, very commonly used for this task, right up there with ImageNet. And we'll define some parameters for our training experiment. Again, all things that are very common. Data scientists are really good at tweaking these and finding combinations to make sure that they train the highest performing model. And so we'll do that right here. And then it's time to get into the training component itself. So we'll first define some configurations about this Sagemaker job, is what it's called, where we're going to call it this demo image classification. And then we'll actually kick off the training experiment, this job right here. And I trained this model yesterday just because it takes a couple minutes. So for demonstration's sake, I took care of this already. However, we can see that the job did complete, just double checked it right here. And what I did was printed out the location of the output or model artifacts. So real quick, I'm going to go into S3, which right here, show you where this model is. All right. You can see all my different Sagemaker experiments I have here. In this case, it's the demo image classification. We were interested in the output. And what we see is this model tarball, the .gz tar file. And this is literally the raw output of this Sagemaker experiment. And this is the point where this model, this file, this model by itself is virtually useless, right? You're not going to gain any business insights or value from this model sitting here in a training, very much training-friendly experimentation environment. So what we're going to do is deploy this to Modzy using our converter service, as I mentioned. Keep in mind that this is the location of that file, which we're going to use to kick things off for our converter service. Now, the conversion itself, or in other words, the upload of this model straight from scratch, takes about 5 or 6 minutes. I'm going to kick this off now and walk through what's going on here. So that in about 5 minutes or so, this will be complete. I'll show you the end product, and then we can even run a sample inference on it, all very quickly. Okay, so to use this service of ours, there are a couple things that you need. First, you need a Modzy account. You need access to the Modzy's Python SDK, and you need to be able to have that installed in the environment where you're working. And so in this case, I have another Jupyter notebook. separated the notebooks, the training and version notebooks for demonstration's sake, but you could put this all in the same notebook and make the pipeline go even faster. But anyways, we need a Modzy instance, then we need a couple other things. We need the model file that we just saved out. We need the location of that model file. And then we need any credentials that you may need to access that file in our storage bucket. And lastly, we need a metadata file and any labels or auxiliary files that I'll talk about in a second. So once we have those things, we can get started. In this case, I've defined some credentials that we'll need to go through this process. I have pointed to the location of my model artifacts. You'll notice this is exactly the file path I just showed you, pointing to this model archive output. And the next step is to upload some other additional resources I mentioned. So there's just two additional files we need. First is this labels file, which is just a JSON that contains a list of all of the Caltech object classes. So what we expect is that this model, or at least a well-trained model, can take an image in as input and predict the output as one of these classes, a goldfish, for example. And the other file is this metadata file, or YAML file. I want to go back to the point I made earlier on about standardization. So the extent to which you fill this metadata file out is optional. It's up to you. But we think that we've included this. We've built out a template that includes all this information that a end user might want to know before using this model in a production setting. So here's where you can define the origins of this model, underlying architectures used, any training data or specific processes, so that the end user has an idea, is this model appropriate for my use case right now? Now, the next, so then we define those two files and we'll upload them to that same S3 bucket. Let's take a look back in our S3 bucket. And what we should see is a new file appear. This resources.tar file. Great. So basically what I did there is I took those two files, zipped them up in another tarball, and uploaded them to the same directory, which we'll need, which our converter will need to access this. Okay. So once that's complete, it's time to instantiate the Modzy API client through their SDK, and then consequently, or subsequently, the converter client that uses the Modzy API client. And in doing so, we are ready to go. We can kick off this job with all the information that we have defined up until this point. So we need to define the source platform. Again, this is Sagemaker. It could be Azure ML or MLFlow, and the process would be very similar. The model type for Sagemaker, there are various model types that Sagemaker will produce and save out. And so you need to specify what you're working with here, in this case, image classification, as I mentioned. And then we will kick off the process. So just using a simple start function that's built into the SDK, we'll pass through our credentials, we'll pass through the S3 bucket specific information, we'll pass through our weights file. So again, just that, this will point to that model tarball, our resources file, source platform, and model type. So let's see, I kicked this off about 4 or 5 minutes ago. It usually takes 5 to 6. So this will complete in a second. While we're waiting on this, what I'll show you is you can do everything I'm showing you in our user interface. So it's a robust interface, and again, the exact same service that I'm showing you that can be all done programmatically, automates things, and makes it much more efficient, can all be done in the user interface as well. So I could go in here and click on Sagemaker, put in my storage bucket, my credentials, and model type as image classification, and go through the same process, which again would be another great experience for me as a user. I'll stop and see if there are any questions while this finishes up. It should finish up in the next 30 seconds or so, and see if anybody has any questions, comments about what we've gone over so far. All right, that's fine because it looks like it just finished, which is great. So what we see here is the model successfully deployed in just under 6 minutes. And now what we can do is click on our newly deployed model. And everything that I showed you in that metadata file will appear on this profile page for this model. There are no analytics data yet because we just deployed it, but we can go in and see what the overview of this model is, how it was trained, validated, all this great information. And then just like that, we have accessibility to APIs to run this model really easily. So as an end user, your developer, pick your platform or you pick your language of choice, copy paste this code, and right away you can get inference results from this model. Just to see what that looks like, we will see how this model performs on the picture of an airplane. It'd take a couple seconds typically, but I don't anticipate that the results will be great, given we just trained this model with 2 epochs very quickly and didn't pass a lot of data through. It should work earlier, quicker. Maybe it got shut down. While that is finishing, any other questions about this? In conclusion, I think what we found is that yes, we trained this model in Sagemaker. I did it yesterday, and anybody can do that, and it would take a little bit longer. This is gonna take a while. Actually, I'm gonna interrupt this because it takes a second for the model to spin up. Yeah, listen, takeaways here is you can train your model in SageMaker, these really common tools, and do that however you like. And that the training time may vary based on the amount of resources you have available, how large the architecture is, how large the data set is, and all these different variables. But in just under 6 minutes, right, we took that model and put it into a production system and application, which makes it really easy to interact with and deploy into any application. So I'm going to stop sharing my screen right now. That is about everything I wanted to cover today. So happy to stick around if anybody has any questions or comments, but thank you all for joining and listening today.